Okay, guys, now let's move on to the second part of our lesson on arithmetic sequences. So here we're given two terms of a sequence, and we are being asked to identify the recursive and explicit form and give the first five terms. So first of all, we have the third term, which is 14, and the fifth term, which is 22. So we are going to use, we're going to use our explicit formula, but we do not have the first term and we do not know the common difference. So let's set up what we do have. So we know that if we had the fifth term, which we do, it would equal the third term plus between the third and fifth term is a difference of 2. So it would be the common difference times 2. So we have 2 of the common differences added to the term 3 would be term 5. Now we're going to plug in what we know. We know that the fifth term is 22. We know that the third term is 14 plus 2 times the difference. So the fifth term of 22 is 14 plus 2 common differences. Now we're going to solve for D to see what the common difference is. So we're going to subtract 14. We're going to isolate the D. And we get 8 equals 2 times D. Divide each side by 2. And our common difference is 4. Now, we need to find what A sub 1 is, our first term. So we can set up a new equation. So let's use A sub 3 since it's closer to A sub 1. So between the third and first term is 2. Okay, so we have A sub 1 plus 2 common differences. Well, now let's plug in what we know. We know A sub 3 is 14. We do not know what our first term is, but we do now know that the common difference is 4. So we have 14 equals A sub 1 plus 8, and now we can isolate the A sub 1 to know what our first term is. So the first term in the sequence is 6. So now we can write the explicit formula, which says A sub n equals the first term, 6, plus the common difference, 4, times n minus 1. Now we can simplify this explicit formula to make it look like the slope-intercept form. So we're going to distribute the 4 and combine like terms. Now we can get any term we want. So if we are looking for the 20th term, we can simply plug in 20 for n. Remember, n represents the location, so we want the 20th term. And we multiply 4 times 20, that is 80, and then 80 plus 2 is 82. So that is how you find the explicit formula when you have 2 terms of a sequence and neither one are your first term. Okay, let's take a look carefully at a word problem. So we had to be really careful here and remind ourselves there's no such thing as the 0th term, so we will not have a y-intercept. A seedling is 3 inches tall and is predicted to grow an additional 4 inches each week. Create the recursive and explicit form to predict the height of the seedling at the end of how many ever weeks that we want to find, assuming that the growth pattern is the same. How tall will the plant be in 12 weeks? So the first thing we always have to do is define what our domain is, what it represents, and what the range represents. So we know that the domain is always 1, 2, 3, and so forth, because we have the first term, the second term, the third term, and so on. But what does 1, 2, 3 represent? Well, if we go back up here, it's going to represent 4 inches each week. So the week number is our domain. So we want to know the height at the end of the first week, the second week, the third week, and we're going all the way until 12 weeks. Now the range is going to be how tall the seedling is at the end of each week. So we will say the range is the height. Now here's where we have to be careful. The seedling was planted at week 0 at 3 inches. So at the end of week 1, it is not 3 inches. It has to have grown 4 inches. So it is 7 inches at the end of week 1, and then it continues to grow 4 inches each week. So then we have 7 plus 4 is 11. 11 plus 4 is 15, and then we'll calculate how tall it is using our explicit formula. So we are going to plug in our first term, which is 7, plus our common difference, which is 4 times n minus 1. So that's explicit. Now let's simplify it. We have 4n minus 4, combine like terms. And here is what we're going to use to find at week 12. So at week 12, we want to know how tall the seedling is. 4 times 12 is 48, plus 3 gives us 51. So at week 12, at the end of week 12, it is 51 inches tall. So identifying what the domain represents, not just what it is, but what it represents, defining the domain and range is super important when you are working with a word problem with a sequence. Okay, let's do one more word problem. A brick staircase begins with 100 bricks on the stair step 1. Each successive step requires 2 bricks less than the previous step. There are 30 steps in all. So let's define the domain and the range and see where we are. So the domain is going to be, again, we know the domain is 1, 2, 3, and so forth. But what does this 1 represent? What does this 2? So we read the sentence again. A brick staircase begins with 100 bricks on stair step 1. So our domain are the steps, and the range are the number of bricks on each step. So on step 1, there is 100 bricks. On step 2, so this time, it actually gave us that first term in our word problem. Then it is decreasing by 2 bricks. So on stair step number 2, there are 98 bricks. On step number 3, there are 96, and so forth. It says how many bricks make up the top step. It says there are 30 steps in all. So we're going out here to 30. So let's write an explicit formula for this situation. So explicit formula says my term number is the first term of the sequence plus the common difference, and this is going down 2, so it's minus 2 times n minus 1. N minus 1, again, represents the previous term. Now let's simplify this by distributing the negative 2. And our explicit simplified form is negative 2n plus 102. So remember, n represents the term position. So on the 30th step, we want to know how many bricks. Let's make that a 30. So negative 2 times 30 is negative 60 plus 102. So